It's great to see you all, and it's always a great pleasure to give an update on the project. Okay, let's start with the team. The team hasn't really changed, but they have become even more proficient and good at what they're doing. I'm merely sharing this, but they go by themselves. So, and that's great to know. Vicky has been absolutely instrumental in getting this conference arranged and all in good order. That's not the only job she does. She's also the application scientist, working out things with practical problems and working with Luca in the screening part with our industrial partners. Gary is in the room there. He is a co-PI on the project, joining in for every one of our, or most of our online work meetings, doing coding, and you're going to see a magnificent slider bar thing in the future releases of the program. Brian is the official secretary of the project. He actually suggested that we hold the conference here as a first go, but he's not here yet. That may be cause for worry, that he leaves us to fend for ourselves, but he has kindly volunteered 2 of his master students to help us out. Now, you all know Ed. If there's any bug, Ed is responsible for it. Every time we have a group meeting, Ed's list has doubled or tripled in size and things that we were doing. Actually, as part of that, we are still looking for somebody who could join the team as a programmer, some programming skills, maybe a bit of NMR knowledge. We can't offer permanent contracts or extended, but certainly we could offer for a year. So if you know about people, have them contact me or anyone on the team. Elisa is in the room also somewhere. She is doing structural calculation and NAF-related work, and she's done a heroic effort together with Charles, who is one of our speakers now, to get this all working. There'll be a little bit more in Vicky's presentation on that one and how we're doing there. And then we have Luca, who is also assisting Ed with sort of core programming things, but also involved in industrial outreach activities. And then for all the way at the end, you see Frankie. We don't have a picture of her yet. She seems to be escaping any opportunity for us to actually take a picture, but she's part of the admin team and she's supporting us. And to all the speakers, she's the one who's going to give you your reimbursement and your forms. So quite important. But she's been great help also getting this organized and relieving us some of the admin work. Morgan is the PhD student now, soon entering completing his 2nd year. He's been magnificent in doing things in the AnalysisMetabolomics program, for which there are slides and showing some of the developments in Vicky's part. Okay, a little bit of what we've been doing. Of course, outreach like this conference is an important part of our remit, and I think we've really also stepped up our effort in doing talks and workshops and presentations. I'm not going to go over every one of them, but these are the ones that we did since last conference in 2022, going to sites in Europe, going to sites in the UK. Here's the ones that we've been doing in 2023, and the workshop in 2 days or on Saturday is not even on this one, and we did 4 alone in June of this year. Okay, so we've been trying and stepping up our efforts to write some more papers. So these are some of the ones that we're doing in the area of screening. There's, you see one in preparation. That's always easy to do. This could be there for a year in preparation, but we've good hope that we will be finishing this before next year's conference. This is one, Morgan and I had a short paper, and a second one coming on the remediation of metabolomics databases. And Elisa worked, like I said, with Charles and a large number of people in the WPDB validation team on restraint validation as part of the validation pipeline. And that one I have listed as submitted, but there's a slight variability or discussion on that one, but it is close to being submitted. Okay. A little bit of notion that actually we are a partnership grant, and we have a large number of partners that you see here on the map. And just a few weeks ago, Ed and I visited the NMR Box people. And I think if there's any of this partner which come close to us and which are sort of doing similar effort, it's probably NMR Box. It was a very useful visit, I may say. So they're located in Farmington at UConn, University of Connecticut. Jeff Hoek is leading this effort. Now, they're home to NMR Box, and for those of you who are not familiar with it and you're starting out or you're struggling with programs and installing and resources, their resource is massive. It's readily accessible, and even at some point for some tests, we wanted 1,000 CPUs and just gave it for us for some calculations, some trying out things. So if you have ideas and you don't have that resource, I would say be in touch with them and see, and they're very happy to help out there. They're also the new home of BMRB. So BMRB has moved from Wisconsin to UConn. And when we were there, we just heard that funding was renewed, although it was not clear at what level of funding that was renewed. If that's just enough to buy some pizzas and a few cups of coffee, it's not going to help us. But let's hope that we're positive, because having a good repository for NMR data, of course, is quite essential. So like I said, we were there for a 3-day work visit, including a 2-day workshop where we went over 6 of our 8 tutorials. And I worked for, because I get this question a lot, actually, we have probably now a working virtual machine which can run the King stuff again. Like, we got that fixed there. Okay, we also have a bunch of industrial subscribers, and that's going quite well. We are over 20, something 22, 23. I don't count them every day. And the good part is that it's growing. And particularly, we have the impression that former PhDs and postdocs are quite advocating them. And then once they move to industry, to all the PhDs and the postdocs here, go and use NMR analysis program suite, and then tell your future bosses to come out and take a subscription with us, because that supports the project quite well at the moment. So Vicky and Vicky are providing the support, and are also engaging with development with our industrial partners, and all those benefits actually do come back to the project, because that's a condition on which we do this kind of things. Sometimes the industrial subscribers have quite specific problems related to installation, so they only have one installation. They want to use proxies to access the internet. They may have non-local, that means not on their own laptop data storage problems, which is sort of counterintuitive from how the program was designed. Again, we're solving these problems with them, and then all these advantages come back to you all. I think it's important to mention some industrial outreach that we have engaged with a company called Omnium AI. So this is an R&D company in Portugal, which specializes in machine learning and AI applications for biosciences. We had an exchange visit where 2 of the developers came to Leicester for 3 years, not 3 years, 3 days, different time frame. And we got a bit of money from a local BBSSC IIA, that sort of these outreach funds where we had some money for. And it was quite successful. So we talked a little bit what kind of things their platform could be doing. We tried out 2 things, and one, for example, in peak selection, it already seems to be pointing that there's some leverage in that direction. So based on that, we now have a follow application pending for a 6-month developer visit to Leicester. So one of the person of their team would come and essentially see how we're could leverage their platform to do some machine learning and AI in an automated way. So let's hope that they will go through. Now, this is important. Version 2, here's some screenshot of your favorite program that you have been using for 20 years and you don't want to stop using. I'm going to announce now that as of January 2025, which is 1.5 years from now, we will no longer support this program. All the functionality has been ported to version 3. We have to spend increasingly resources to maintain that and get distribution. Python 2.7 is no longer supported, is not secure and otherwise, and doesn't. So yes, I'm putting this out here now. I will put it out one more time next year. So you should not be surprised at all that we don't support this anymore from that moment. Of course, the code is all there if you still want to compile this and you want to get this on your Windows or Linux box. Instead, I'm announcing the release of version 3.2, which has a number of advantages. First of all, we've moved to Python 3.10, PyQt 5.15.7, so we're fully up to date there. We've been doing more code cleaning. We're slowly removing V2 remnants that are being limiting us at the moment to further develop the program. As a consequence, the program has become faster. As soon as we keep removing overheads, and we, of course, Python 3.10 is quicker. Importantly, we're doing what we call plugins for external code development. We have now a number of groups, and I think Vicky will show you a few examples of them, where people are actually taking the code base and developing code themselves to enhance the functionality of the program, which is an excellent development. I'm really, really happy about that one. So we have lots of new features that Vicky will show you. And with that, I'm going to hand over to her.
Okay, right. Yeah, so this is stuff which has sort of been gradually added to the program over the past year. And it starts with some, some things are quite small, but actually they're really important to people, such as being able to rearrange your peak labels. You can now do that. So with AV, you'll rearrange your peak labels automatically. And you can now then also, if you can select a peak label with the middle mouse button, you can then move it around manually as well. This is particularly useful if you've got peaks that are overlapped, for instance, so you can automatically separate the peak labels, then select just that peak label. That peak will be selected and you can then pull them apart, which is the kind of thing that was a bit of a nuisance beforehand. And yes, all the functionality is in the mouse menu there, and you can obviously reset the peak labels again if you want. Navigation. We have endless discussions about how to improve the navigation, because you can very easily, on the one hand, you want lots of different options to be able to navigate in whatever way you want. On the other hand, the options quickly get out of hand, and how do you quickly find the option that you want? So we've added a few things to this menu here. You can see, first of all, there's a little pin here. So we've enabled being able to pin a strip. You can see this one here is pinned. I'll show you in a moment how you do that. So that one automatically goes to the top of the list, and you can find that easily. There's one that's highlighted in orange. That's the one that you were last in before you moved to the one where you wanted to navigate from. So you can click into where you want to go, then do your navigate to, and it'll automatically, you'll see that one. You can also see some of these here in italics. That's because these are strips which are not actually visible. You can see here there's a scroll bar, so there are some that are not visible, so those are in italics. So we still need to do some documentation on this, so it's all a bit coded at the moment. This is the pinning. So basically, there's a new menu on your strip ID. If you right click, you can pin and unpin. You can also shift click to do it very quickly. And then Ed also added a very cool feature that when you go to this menu, it automatically highlights the strip. Auto backups or backups. In principle, these have been there for a while. They've gone through various iterations of working-ish, not working. At one point, the auto backups were crashing my analysis every time it tried to do an auto backup. At that point, we decided we really needed to do something. And so we've completely rewritten our XML loaders and writers. And so we've now got a much better system. You can see a project is always in this CCPN folder. It's actually this CCPN v3 folder that has all of your project data in it. And so what we now have in your backups folder is every time you do a save, you get a backup. And if you have the auto backup on, then it will also do an auto backup every X number of minutes. So all you then have to do is swap one of these folders for that one, and then you can restore your backup. We do have plans to make it even more user-friendly, but that will take a bit more time. In the preferences, you can set how many of these things you want to keep and store. We've already had several people just in the past couple of weeks who've managed to rescue projects using this. It seems to be working well. You can, of course, also archive projects that will store the whole of the .ccpn folder. Validate paths. This is basically just showing all the paths for your spectra, but it's become much more user-friendly. We've always had this system of being able to have either sort of relative paths or having absolute paths. You can now switch between them really easily by just clicking make absolute. And we've got a search and replace, so you can easily change lots of paths in one go. Very useful when you're got hundreds of screening spectra. Read-only mode. We had someone who was trying to access their students' data, didn't have write access, and then the program fell over. So we've now got a read-only mode. You can read projects off folders you only have read access to. We've also introduced this little padlock, which usually is open, so you can save your project. But perhaps if you want to give it to your supervisor to look at, you may wish to lock it first. and then they won't save all sorts of weird and wonderful things that they've done to it. The double quantum diagonal from version 2 is back again for those who, perhaps particularly solid state people who are doing double quantum experiments. You just, in your spectrum properties, set your coherence order to double quantum and select the other isotope code, and off you go. We're now this week just adding in a new macro, which will give you some assignment statistics. It gives you a range of different sort of summary and rather more detailed tables. I think this is actually sort of the beginning of what will hopefully end up being quite a comprehensive sort of quality control set of tools. You can now easily create disulphide bonds. So once you've added your sequence, you can go to molecules, edit molecular bonds, and then you select disulphide bonds, select your 2 cysteine groups that are bonded, and add the bond in. You can always delete it again. We've made this in quite a general way so that ultimately we can also add other bond types, so that things like acetylation or phosphorylation, things like that, can also be added in quite easily. This was something that came out of working with people who are doing peptide work. Another thing that came from that is this little multiplet peak picker. So basically it will automatically detect your split peaks and put them into multiplets. And you can see here a multiplet peak list. It always shows the constituent peaks. The positions are averaged, the heights and volumes are added, so that you can then use those for later things, and so that your chemical shifts all stay in the correct place. As we're doing our work, of course, we're always trying to look for synergies. Where can we sort of save on writing code, basically? And something like, obviously, chemical shift perturbations is something you're basically just looking at. How is the location of my peak changing? And then you're wanting to do some kind of fitting. Dynamics, rather than it being the position of the peak that changes, it's just the height. And again, you want to do some kind of fitting. Then the heteronuclear NOE, this time we don't have a full series. We've just got 2 values and want the difference. J couplings, again, it's a difference, but this time in position rather than in height. So you can see it's all sort of doing similar sorts of things. So Luke has actually taken our old chemical shift perturbation module, has rewritten it so that we can then reuse it for these other situations. And the nice thing about that is not only does it make it quicker for us, but it also means that as a user, you will actually have an experience that will be similar across different functionalities. So it'll hopefully be easier to use the program. So this is now what the chemical shift perturbation analysis would look like. Everything's in the settings module. Here we're just going to follow all the peaks that we're going to group the peaks together that have got the same assignment. And once we've done that, we're going to extract all the information we need to create into a table. So all the peak positions and things, the assignments, and then we can do our fitting, and you can change appearance and things. And then looking at the data is similar to what it was before. You can move through the table, look at your fittings graphs. You can navigate from your bar chart, and in the spectrum, you always go to the corresponding peak. And interactively, you can also change the threshold. And as you'll see in a moment, we've got something very similar now working for the dynamics. So here we're selecting some T1 data. This time, rather than, we haven't actually picked all the peaks yet, we're going to pick them at the same position and refit them there. So slightly different way of grouping our peaks, but again, essentially we're doing the same thing. Now we're creating our input table, extracting all the data from the peaks, doing our fit, and setting our appearance. And once again, you can then get your rates out of the table. You can export things. You can export all your tables either to CSV or to Excel. You can export your bar charts as images, but we've also then got a macro that will create various PDFs of key parameters. So here R1, R2, heteronuclear NOE, and you can add in your secondary structure if you want to have a little chart alongside it, and various other things. You can do reduced spectral density mapping. And I think probably the next thing to be added will be the CEST experiments. And so again, modeled on this, we'll then also be doing a similar module, which will look at J-couplings and RDCs. In AnalysisStructure, we haven't added an awful lot of functionality, but we've streamlined and improved a lot of what is there. So for instance, this is if you want to compare data from different runs, all you have to do is just drag in the different structure runs that you've done, and then you immediately get your comparison table, and you can compare the restraints from the different runs. In this case, it was 2 consecutive runs on Explore. It could be parallel runs that you did on different programs, you know, Explore, ARIA, and Cyana, compare how did they do their assignments, that kind of thing. On the NEF front, things continue to go ahead. So we've got really nice integration with Explore. Integration with ARIA has really come a long way now. There's actually on YouTube, a video from our NEF workshop back in November, where Benjamin shows how you can use NEF to link with ARIA. The public version, I think, doesn't yet have the NEF integration, but the developer version does. He's generally always very happy to give that to people if you ask for it. And I think the tutorial probably also has the link for the developer web server, so you can use that. The other thing to highlight here is NEF pipelines. I think Gary might talk about that tomorrow. He's got a poster. That is a nice way to edit your NEF files, but also to use it to convert to other programs. So he's linked it to a variety of programs, some with read and write, some just reading or writing. And that may also be a way to, in future, to move to Cyana, because they're still being a bit slow about getting Cyana right up to scratch on the NEF front. So to sort of cover all these things, we've created a few new tutorials. They're quite an easy introductory one, some solution NMR ones, and then a whole series of NEF related tutorials. So those are all on our website. AnalysisScreen, again, perhaps hasn't had a huge amount of dramatic stuff done to it this year, but we have continued our work together with Novartis. The automated workflows are working really nicely. We're now getting really reliable peak matching, or I should say, not just reliable peak matching, but we're reliably telling you which ones haven't matched, so that you then only have to look through 5% of your peaks to check actually what's the identity of that peak. And we've got easy navigation tools and filtering tools for you to do that. So our collaborators have found that the time to analyze one of their data sets has gone down from 3 days in Topspin. Oh, there's a question. We'll come to that in a moment. From 3 days to less than an hour. So that's quite impressive, I think. And it's also enabled them to implement their much larger library now of fluorine-containing compounds. And as Geerten said, we've hopefully be starting to write the paper soon. We're just waiting for Luca to finish off writing reports so that you can automatically just say, these are my hits, generate your PowerPoint slides that you then need to show your boss in your next meeting. Morgan's work on AnalysisMetabolomics is really coming along now. What he started off doing is creating a CCPN database of metabolites. So he's started off with these various free databases that are available, read in all of that data, merged it, curated it, but importantly, annotated and stored it in a way that he can then simulate spectra from that data. Because of course, if somebody's deposited a spectrum, it's been recorded at a particular temperature, a particular pH value, a particular field strength, and that might not correspond to what you've been recording your mixture at. And so you need to be able to manipulate that reference spectrum and adapt it to your mixture so that you can make that nice comparison. So what that then looks like when you're simulating them is this. So here we've got a mixture at the top. Below we've got all our various reference spectra. And you can see, because it's simulated, we can now move this around, and this second spectrum is actually a sum of all the references. And so you can see, you can just move things slightly just to adjust for the changing conditions and sort of recreate your mixture correctly. You can also add, if you've got any unknown signals for which you don't have a reference, you can add those in manually. So you can just pick those peaks and then create signals in those positions, adjust the height and the width to fit that, and store that as a new compound. You can also go a bit further and use spin system matrices. So here on this diagonal, we simply enter the different chemical shifts, and then you get at each of those chemical shifts a new signal appearing. And then in the off diagonal elements, you add in your J couplings, and then you can see how gradually the spectra adjust. So that's quite nice. What's going to be coming next is creating automated methods to match or identify your metabolites, your references in your mixtures. What I want to finish off with is the way in which we're progressing with developing analysis as a development platform. What do I mean with that? Well, you probably know that our program is written in Python, and we deliver our program with a version of Python. But of course, it doesn't just include Python, it includes lots of other libraries that have been created by other people. And that's continually growing. So part of the reason for moving to 3.2 is that we've added a few extra packages in. It includes lots of standard libraries for doing data analysis and chugging through lots of numbers. Qt is for the graphics, but we've also got here some NMR specific things, NMR glue, NMR sim, that's what Morgan was using for his simulation things. Scikit-learn has some machine learning capabilities. We can read and write to Microsoft Office, and also new now is Pluggy, which will help improve the way in which we can let other people develop plugins. And on top of all of that, of course, you get all of our code that we've written to all of our routines to read, store, display, and manipulate NMR data. And so how we're envisaging this is that on the one hand, people can write macros. So this would be to sort of customize things for you as a user, create bespoke workflows, develop perhaps some standalone functionality. That's something that even novice programmers can do. So we've got some tutorials. This is our main macro writing tutorial, but we're about to launch another one which will show you how to start doing your own graphical pop-ups and things. But then as well as macros, as we've mentioned, we're moving towards people being able to do plugins. So I mean, you probably heard about plugins from other programs, whether it's WordPress or Firefox and things like that. And it's the same principle. It's a way in which people can then actually start to integrate their code with our code, get inside our modules, our menus, and all of that kind of thing. So obviously that is rather more aimed at intermediate and advanced programmers. And we've got a number of people who are already doing that kind of thing. So Rudy up there has got a poster about a plugin he's busy writing at the moment. Uluk tomorrow is going to give us a talk about a plugin that he's been developing. This is, I'm just going to show you briefly some work done by one of Harry Athanari's students, Harrison Wang. You may know that Harry has been working on methods to enable assignment of very large proteins. Initially, they're using this special pyruvate labeling scheme. More recently, it's not yet published, they've developed some pulse sequences, they're calling them GradCops, which basically do sort of partial C-beta decoupling. And the upshot is that when you're doing your backbone walk, your backbone matching, you're matching not just on the chemical shift, but also on the peak shape. You get information about the amino acid, and crucially, you can also back calculate what the C-beta chemical shift would be, although all you're recording are actually HNCAs. And so Harrison has written a pop-up where you basically do our normal backbone assignment routine. This is the peak we're searching for. We've got some possible matches over here. But as well as getting these normal strips, you get an additional window where you can compare peak shapes. So that's the one we're trying to find. And you can see that here, obviously, this top one is the one that matches best. He's also then modifying our assignment probabilities with his code. You can, as I say, back calculate the C-beta chemical shift, and then he's using that to modify it will add to the chemical shift, the amino acid type prediction. And so that really brings us to perhaps what we're sort of hoping and envisioning for the future, which is really to emphasize the collaborative bit of a collaborative computational project for NMR, so that really other people can contribute as well. We're going to be launching a macro library, but also, if they wish, it's a way to reach a big global user base or serve a global user base. And hopefully together we can then also do things like documentation, workshops, etc. So we hope many people will join in with us in this way. Looking to the future, I feel very aware that last year I said, oh, we're going to be doing lots on assignment. And we've crossed off quite a few things off our list, but that's what's still left. So we're going to continue chugging through that list. I think the two big things really are going to be speeding up strips. So that's going to be Ed occupied for a little while. He's already made some progress with that, but I think he's got more work to do. And also having a more generalized peak matching feature. Synthetic peak lists is a big one again that we're really keen to crack. Increasingly, people are asking us about RNA functionality. I think we've got someone to give us some data as well. So watch that space. We've got lots of people working with peptides. It's a growing area, really. So there's a few smallish things that we can do to improve that, hopefully. And obviously, we want to continue to work with people who are creating plugins and sort of streamline that process. And with that, thank you to all the people who've been involved with all of our work. I should have said on the metabolomics, actually, Marie has been really helpful on that in helping Morgan along. So thanks everyone who's been part of this.